This is the 4.1 notes video. I apologize for my voice, and if I cough or anything, I'm not feeling great this evening, but I wanted to go ahead and make this video because we have already spent 2 days on 4.1. So the first thing that we did on Thursday is we looked at these 4 graphs, and we talked about how we could use a graph in order to write an equation. So these graphs are nice because we can actually see the y-intercept even if it's not labeled. It's the point at which the graph is touching the y-axis. And we can also calculate our slope by using our slope triangle, which is just counting how many you move up and over to get back onto your line. If we know our slope and we know our y-intercept, then that allows us to write an equation in slope-intercept form, which we spent quite a bit of time in Chapter 3 talking about. So slope-intercept form is y equals mx plus b. Remember, m is your slope, so that coefficient of x, or that number in front of x, is your slope, and then b is your y-intercept. So that's that number that's either being added or subtracted. Okay? Then we reviewed how to use your graphing calculator to verify your equation. So that's when we went into y equals and we put our equation that we wrote, and then we made sure that it matched the line that we see on our paper. Okay, so I'm going to do A and C to get you guys started and make sure that you remember this, and then we'll move on. So if you look at letter A, this one is a little more basic because they actually labeled your y-intercept for you. You can see that right here, this 0, -1 is where the graph is touching the y-axis. So I'm going to start by writing y equals, and I know it's something times x minus 1. I know that it's minus 1 because that's b, that's the y-intercept. Okay, so now I need to figure out, well, what's that coefficient of x? What is that slope? So remember, you start on your y-intercept and you count. How many would you have to rise to get in line with that second point? So you would need to rise, so I'm counting from here up. You would have to go up 4 units. And then how many would you have to go over to get on that point? You would go over 2. So if you rise 4 and run 2, that would give you a slope of positive 2. So I know that the number in front of x had to be 2. So my equation in slope-intercept form, what I think the equation is y equals 2x minus 1. So then we used our graphing calculator in order to verify that. So just so you remember the steps, once you turn your calculator on, you're going to press y equals, and then you're going to press 2x minus 1, and then press graph. The graph you see on your screen should match this graph right here. Okay? All right, let's go ahead and look at C. So C, they did not actually label the y-intercept. However, I can see that the graph is touching the y-axis right here at positive 1. So I know that this equation is going to be y equals something times x plus 1. Notice b is positive here, so I wrote plus 1 because it touches at positive 1. Up here, b was minus 1 because it touched at -1. Okay? All right, so then we can calculate our slope, and you can do this a couple of ways. You could start from the y-intercept and see how many you have to go down in order to get in line with the point. And I actually needed to go down 2. So remember, when you move in a downward position, you write -2 as your rise, or your top number, your change in y. And then how many would I go over to get on that point? I would have to go over 3. So I know that my slope must be -2/3. Then that's what we think our equation is, so we're going to put that in our calculator and make sure that it matches the graph that we see. Don't forget, when you put -2/3 into your calculator, you need to make sure you put it inside parentheses. Anytime you have a fraction, you need parentheses, and then that x would be on the outside of those parentheses. Okay? Notice here I have a negative slope because my line is sloping down from left to right. Notice up here I have a positive slope because my graph is sloping up. So after we finished those couple of examples on our notes, we moved on, and instead of giving you a graph, I just gave you some information. So notice the instructions say to write the equation of each line with the given characteristics. So we talked a lot about this and how you know what form of a linear equation you should be using, and you figure it out based on what they give you. So if they give you slope and a y-intercept, like on letter A, then you should be using slope-intercept form. Notice the name, slope-intercept, when given slope and the y-intercept. Okay, so I'm going to write my first equation in slope-intercept form. So that would be y equals, and my slope is -3, so we have -3x, and my y-intercept is a half, so plus a half. So in slope-intercept form, that would be y equals -3x plus a half. All I did was replace m, which is your slope, with the slope they gave me, which was -3, and I replaced b with a half because they gave me the y-intercept as a half. Then at this point we learned a new form of a linear equation called point-slope form. Notice if they give you a slope and a point, you're going to use point-slope form. Okay? So the first thing that I encouraged you to do when you're given a point is to label it. And since they gave me 1 point, I'm labeling it x1, y1. I do that because I am going to be using this formula, which has x1 and y1 in it. I'm also going to be using the slope, but we should all be familiar with the fact that slope is m in your equation. So the point-slope form is y minus y1 equals m times x minus x1. They have given me m, and they have given me x1, y1. So I am going to substitute those values into this formula. So I will have y minus, and notice y1 was 5. So y minus 5 equals my slope, which is 4, times x minus, now notice here my x1 happens to be -2. So minus a minus becomes plus 2. And I allowed you to leave your equation in point-slope form on day 1 of our notes. So this is y minus y1 was 5, equals m, which was 4, times x minus, but since it was -2, it became plus 2. Okay? So this portion of your notes actually began on day 2 of our notes on 4.1, but I am including it in one video. So I'm combining day 1 and day 2 into one video for you guys. So at this point, we are still writing equations, but they're giving me some different information. So notice the instructions say write an equation of each line that passes through the given points. And they're actually giving me 2 points this time. So step 1, I told you guys to label and calculate your slope. So this is step 1. I'm going to label my points x1, y1, and x2, y2. That's going to help me with my slope formula. Okay, so remember in slope formula you do y1 minus y2 and x1 minus x2. Okay, so I'm going to substitute my values in. I have 5 minus -1 over -3 minus 0. I'm just using my formula. I took my points and I substituted them in. Now I'm doing the computation. 5 plus 1 is 6. -3 minus 0 is -3. And when I divide 6 by -3, I get -2. This is my slope. Now, given a slope, and I have at least 1 point, now I'm going to use point slope. Okay, so step 2, I'm substituting my values into point slope, which is y minus y1, which in this case is 5. I got that from right there where I labeled my points, equals my slope, which I calculated as negative 2, times x minus x1, which in this case was negative 3. So notice my minus became a plus 3. Okay, so now I've done step 2. Now I'm going to move on to step 3, which is to solve for y. So this is from chapter 1. We learned how to solve equations in chapter 1, and you guys are getting great at it. If you're still a little weak here, this is something that you need to be coming in for tutoring for some extra support. So step 1 is to distribute. So I get y minus 5 equals negative 2x minus 6. The opposite of subtracting 5 is adding 5, because remember, we're solving for y. That means we want to get it all by itself. And that gives us y equals negative 2x minus 1. And this would be my final answer. Okay? Okay, so we did several examples of this in class, and then we also did an activity that where you were using this same information. Let's go ahead and move on to that next section where we can see another example. So notice that this problem is very similar to the last one, only we see that they're using function notation. So what that does is it adds an extra step, but really step 1 and 2 are basically one step. So they are giving me f of 0 equals 10. Well, that's just an x and y value. So I have an ordered pair of 0, 10. Then they gave me f of 6 equals 34. So that ordered pair would be 6, 34. I'm still going to label that as x1, y1, and x2, y2, because I know I'm going to be calculating my slope. Okay? So then from here, I'm going to subtract. I have 34 minus 10 over 6 minus 0. That gives me 24 over 6, which is equal to 4. So I have now calculated my slope. Now I told you guys before that you do not have to memorize this slope formula because it will be on your formula chart along with slope-intercept form, point-slope form, and the standard form of a linear equation. Then from here I'm using point-slope, which is y minus y1, which in this case is 10, equals your slope, which you just calculated as 4, times x minus x1, which in this case happens to be 0. The last step is to solve for y. So I distribute. That's going to give me y minus 10 equals 4x. Notice 4 times 0 just goes away. The opposite of subtracting 10 is adding 10, so I do that to both sides. And I wind up with y equals 4x plus 10 for my final equation. Okay, so the 4.1 notes were very process-based. There were a lot of equations, so if that's something that you're still struggling with, I encourage you to come in for tutorials. You'll have a great night.